What if I told you that a tiny change, something so simple you'd think it was a joke, reduced tractor breakdowns by 73%? And what if I told you it took 15 years for anyone to figure it out? This isn't about fancy technology or expensive parts. This is about one small tweak that saved millions of dollars and countless hours of frustration. Before we dive in, hit that subscribe button because we're about to uncover one of the most overlooked engineering solutions in agricultural history. Let me take you back to the 1970s. Tractors were breaking down everywhere, not just occasionally. We're talking about catastrophic failures that left farmers stranded in the middle of harvest season. The financial losses were staggering. Insurance companies were hemorrhaging money on claims. Manufacturers were scrambling to figure out what was going wrong. These weren't cheap machines. A single tractor could cost as much as a house, and they were failing at an alarming rate. The weird thing, the breakdowns didn't follow a logical pattern. Brand new tractors would fail within months while some older models kept chugging along for decades. Engineers examined everything. They tore down engines, analyzed hydraulic systems, tested transmissions under extreme conditions. They assumed it had to be a design flaw, maybe a weak component that couldn't handle the stress. So they reinforced parts, upgraded materials, added redundant systems. Nothing worked. The failure rate stayed stubbornly high. Here's where it gets interesting. A young engineer named Robert Chen was assigned to investigate field reports from farmers, not the technical data but the actual stories from the people using these machines every single day. Most engineers didn't bother with this approach. They trusted the numbers, the lab tests, the controlled environments. But Robert had grown up on a farm. He knew that real-world conditions were messier than any laboratory could replicate. He spent months visiting farms across the Midwest. He talked to hundreds of farmers, watched them work, asked them about their routines, and he noticed something peculiar. The farmers whose tractors lasted longer had one thing in common. They all did something that seemed completely unrelated to mechanical maintenance. They kept their cab windows open during operation, not for ventilation or comfort, they just preferred it that way. Meanwhile, the farmers with the most breakdowns, they always operated with their windows closed, especially during hot weather when they cranked up the air conditioning. Robert's initial reaction was to dismiss this observation. How could window position possibly affect mechanical reliability? It seemed absurd, but he couldn't shake the correlation. He started digging deeper, looking at environmental data from inside the cabs, temperature readings, humidity levels, air pressure differentials. Then he found it, the smoking gun that would change everything. When farmers operated their tractors with windows closed and air conditioning running at full blast, they created a significant pressure differential between the inside of the cab and the outside environment. Modern tractor cabs are designed to be sealed environments, protecting operators from dust, noise, and weather. But this sealing had an unintended consequence. The air conditioning system pulled air out of the cab faster than it could naturally replenish through the ventilation system. This created negative pressure inside the cab. And here's the critical part. That negative pressure didn't stay contained in the cab. It affected the entire tractor. You see, tractors aren't built like cars with completely separate compartments. There are dozens of connection points between the cab and the engine compartment. Cable passages, hydraulic line feeds, electrical conduits. Each one of these represented a potential pathway for air movement. The negative pressure in the cab acted like a vacuum, pulling air from the engine compartment through every tiny gap and opening. This constant airflow had a devastating effect on one specific component: the air filter. Tractor air filters are designed to handle dirty, dusty conditions. They're robust pieces of equipment built to trap particles before they enter the engine, but they're designed for air to flow through them in one direction, from outside to inside. The negative pressure from the cab created a reverse flow situation. Air was being pulled backward through small gaps around the air filter housing. This bypass air was completely unfiltered, dust, dirt, tiny particles of debris all flowing directly into the engine intake system, not in huge quantities, just a small, steady stream of contaminated air, hour after hour, day after day, season after season. These microscopic particles acted like sandpaper inside the engine. They scratched cylinder walls, damaged piston rings, contaminated oil, and wore down bearings. The damage was so gradual that it didn't show up in routine maintenance checks. By the time symptoms appeared, the internal damage was already catastrophic. Engines that should have lasted 20 years were failing in 5. Robert presented his findings to the engineering team. The reception was mixed. Some colleagues were skeptical. The idea that cab pressure could cause engine failure seemed far-fetched, but the data was undeniable. Robert had documented pressure differentials, tracked particle counts in engine oil samples, and correlated failure rates with cab operation patterns. The evidence was overwhelming. Now came the challenge: how do you fix this? The obvious solution would be to redesign the entire cab ventilation system, maybe add pressure equalization valves or upgrade the air conditioning units. But that would be expensive. It would require recalling thousands of tractors, retooling production lines, and redesigning components. The cost would run into hundreds of millions of dollars. Robert proposed something radically different. What if instead of redesigning the cab, they simply modified the air filter housing? The problem wasn't the filter itself. It was the gaps around the housing that allowed air to bypass the filter when negative pressure occurred. By adding a simple rubber gasket and improving the seal around the filter housing, they could eliminate the bypass airflow entirely. The modification cost less than $15 per tractor. $15, that's cheaper than an oil change. The engineering team was doubtful that something so simple could solve such a massive problem, but they agreed to test it. They selected two groups of tractors. One group received the modified filter housing, the other group continued with standard equipment. Then they waited. The results were staggering. After 1 year of field testing, the modified tractors showed a 73% reduction in engine-related failures compared to the control group. 73%! The oil analysis from modified tractors showed dramatically lower particle counts. Engines ran cleaner, smoother, and more efficiently. The simple gasket modification had solved a 15-year mystery. But here's the question that haunted everyone involved. Why did it take 15 years to discover this? The answer reveals something profound about how we approach problem solving in engineering and in life. Everyone assumed the problem was complex, so they looked for complex solutions. They focused on the obvious components: engines, transmissions, hydraulic systems. These were the big, expensive, complicated parts. Surely the problem had to be hiding in there somewhere. Nobody thought to look at the interaction between systems. The cab and the engine were designed by different teams, tested separately, and treated as independent systems. The idea that cab pressure could affect engine longevity simply wasn't on anyone's radar. This is called siloed thinking, and it's one of the biggest obstacles to innovation. Robert's breakthrough came from taking a different approach. Instead of starting with the engineering specs, he started with human behavior. He watched how people actually used the machines in real conditions. This human-centered perspective revealed patterns that lab tests couldn't capture. It's a reminder that sometimes the best solutions come from observation rather than calculation. The story gets even more interesting when you look at what happened next. The modification was rolled out across all new tractor production within 6 months. But what about the hundreds of thousands of tractors already in service? The company faced a dilemma. They could issue a recall, which would be expensive and complicated, or they could quietly implement the fix on new models and hope word didn't get out about the older ones. To their credit, they chose transparency. They issued a service bulletin to all dealers and offered free modification kits to any owner who wanted one. The response was incredible. Farmers who had been struggling with repeated breakdowns suddenly had reliable machines again. The modification took less than an hour to install, 1 hour to fix 15 years of problems. The financial impact was enormous. Insurance companies saw their payout rates drop dramatically. Manufacturers saved millions in warranty claims. Farmers experienced less downtime and lower repair costs. The total economic benefit was estimated at over $2 billion in the first 5 years alone, all from a $15 gasket and a better seal. This story raises an important question about modern engineering. We live in an age of incredible technological advancement. We can design machines with computer precision, test them in virtual environments, and optimize every component for maximum performance. But sometimes we get so focused on complexity that we miss the simple solutions right in front of us. The tractor gasket modification has become a case study in engineering schools around the world. It's taught as an example of systems thinking, the importance of field research, and the value of questioning assumptions. But it's also a cautionary tale about the limits of laboratory testing. Real-world conditions are messy and unpredictable. Human behavior introduces variables that no computer model can fully capture. There's another lesson here about expertise and fresh perspectives. Robert Chen was a junior engineer when he made this discovery. He wasn't the most experienced person on the team. He didn't have decades of tractor design under his belt. What he had was curiosity, a willingness to challenge conventional wisdom, and the humility to learn from farmers rather than assuming he knew better. The senior engineers had been staring at this problem for 15 years. They had all the technical knowledge, all the resources, all the experience, but they were trapped by their own expertise. They knew so much about how tractors were supposed to work that they couldn't see how they actually worked in practice. Sometimes being an expert can blind you to obvious solutions. This phenomenon isn't unique to tractor engineering. It happens in every field. Medical researchers miss simple treatments because they're focused on complex pharmaceutical interventions. Software developers create elaborate solutions to problems that could be solved with a few lines of code. Business leaders implement complicated strategies when simple changes would be more effective. The key is maintaining what Zen Buddhists call beginner's mind, the ability to look at familiar problems with fresh eyes, to question assumptions, to consider that the solution might be simple rather than complex. This doesn't mean ignoring expertise or abandoning rigorous analysis. It means balancing technical knowledge with curiosity and openness. Looking back at the tractor story, there were warning signs that everyone missed. Farmers had been reporting the connection between cab operation and reliability for years, but their observations were dismissed as anecdotal. Engineers trusted their instruments and tests more than they trusted the people actually using the machines. This is a common mistake in product development. The users of a product often understand it in ways that designers never will. They see it in context, operating under real conditions with all the variables and complications that come with actual use. Dismissing user feedback as unsophisticated or uninformed is a mistake that costs companies billions of dollars every year. Robert's genius was recognizing that farmers weren't just complaining about problems. They were offering clues to the solution. When they said their tractors lasted longer with windows open, they weren't imagining things. They were observing a real phenomenon. Robert's job was to figure out the mechanism behind that observation. This is what good engineering should be, not just designing products in isolation but understanding how those products exist in the real world, how people use them, what conditions they operate under, what unexpected interactions might occur. It requires humility, curiosity, and a willingness to get your hands dirty doing field research. The tractor modification also highlights the power of small changes. We're conditioned to believe that big problems require big solutions, that if something is going wrong at a massive scale, the fix must be equally massive. But often the opposite is true. Small interventions at critical points can have enormous ripple effects. Think about it, a $15 gasket reduced breakdowns by 73%. That's an incredible return on investment. But more than that, it's a reminder that we should always look for the leverage points, the small changes that have outsized impacts. In complex systems, these leverage points are often hidden in unexpected places. The story also demonstrates the importance of cross-disciplinary thinking. Robert's solution came from combining mechanical engineering knowledge with an understanding of fluid dynamics and human behavior. No single discipline held the complete answer. The breakthrough required seeing connections between different fields. This is increasingly important in our specialized world. We train people to be experts in narrow domains, deep knowledge in specific areas, but the most interesting problems exist at the boundaries between disciplines. Solving them requires people who can speak multiple languages, who can see patterns across different fields, who can synthesize knowledge from diverse sources. What can we learn from this 15-year journey from problem to solution? First, never underestimate the value of simple solutions. Before you invest in complexity, make sure you've exhausted the simple possibilities. Second, listen to your users. The people interacting with your product every day see things you'll never catch in a laboratory. Third, watch out for siloed thinking. Complex products are systems, not collections of independent parts. Understanding the interactions between components is just as important as understanding the components themselves. Fourth, maintain beginner's mind. Expertise is valuable, but it can also create blind spots. Stay curious and question your assumptions. Fifth, invest in field research. Real-world conditions matter. What works in a controlled test environment might fail completely under actual use conditions. Sixth, look for leverage points. The most effective solutions often involve small changes in critical locations rather than massive overhauls of entire systems. The tractor gasket story is ultimately about humility. The humility to admit that a 15-year-old problem might have a simple solution. The humility to learn from farmers instead of dismissing their observations. The humility to question established wisdom and try something different. This kind of humility isn't weakness. It's the foundation of genuine innovation. Today, that simple gasket modification is standard on virtually every agricultural tractor produced worldwide. Millions of machines incorporate this $15 fix. Breakdowns have plummeted, reliability has soared, and it all started with one engineer who was willing to listen, observe, and think differently. Sometimes the smallest changes make the biggest difference. You just have to be willing to see them. Now I want to take this lesson and apply it to something you might be facing right now. You probably have problems in your own life or work that feel insurmountable. Things you've been wrestling with for months or maybe years. You've tried solutions that seemed logical. You've put in the effort. You've done the research, but nothing has worked the way you expected it to. That frustration is real and it's completely understandable. But what if the answer isn't more complexity? What if you're like those engineers, so focused on the complicated possibilities that you're overlooking something simple? What if the solution is hiding in plain sight, waiting for someone to approach the problem from a different angle? This is where the tractor story becomes personal. The principles that solved a 15-year engineering mystery apply to everyday challenges too. Start by observing, really observing, not just thinking about your problem in theory, but watching how it actually manifests in practice. Talk to the people involved, not to confirm what you already believe, but to genuinely understand their perspective. What patterns do they notice? What small things have they observed making a difference? Challenge your assumptions about complexity. When you catch yourself thinking that the solution must be difficult, pause and ask why. Is that actually true, or is it just what you expect? Sometimes we resist simple solutions because they feel too easy, like they can't possibly address such a big problem. But that's not how systems work. A small change in the right place can cascade through an entire system. Think about the interactions between different parts of your situation. Most of life's problems aren't isolated. They're connected to other factors in ways we don't always see. The breakthrough often comes from understanding how these pieces interact rather than trying to fix each piece separately. Be humble about what you think you know. Expertise and experience are valuable, but they can create blindness too. Try to approach your problem like you're seeing it for the first time. What would you notice? What questions would you ask? What would surprise you about how things actually work? The tractor story also teaches us something about persistence mixed with flexibility. It took 15 years to solve that problem, but the solution didn't require 15 years of effort once Robert started looking in the right direction. Sometimes getting stuck is actually about looking in the wrong place. The moment you shift your perspective, things can change remarkably quickly. Consider the farmers who had been living with those breakdowns. They didn't give up. They adapted. They kept their windows open because they'd noticed it helped even if they couldn't explain why. They worked with the system as it was while hoping for something better. That kind of pragmatic persistence is underrated. It's not glamorous, but it gets you through until the real solution arrives. There's also something important about sharing discoveries. Once Robert figured out the gasket solution, the company could have kept it secret, using it as a competitive advantage on new models while letting older machines continue to fail. But they chose transparency. They offered free modification kits. They spread the knowledge. And in doing so, they created enormous goodwill and probably avoided massive lawsuits. This principle applies beyond engineering. When you discover something that works, when you figure out a solution to a problem you've been wrestling with, sharing it multiplies its value. It helps others. It builds trust. It creates a community of people solving similar problems together. The world moves forward faster when we share our breakthroughs rather than hoarding them. The tractor modification is also an example of how small investments in the right place can yield enormous returns. $15 per tractor. That's almost nothing in the manufacturing world. The cost of implementing this change across production was minimal, but the benefit was measured in billions of dollars. It's a powerful reminder to look for those high-leverage interventions. Think about your own situation again. What would a $15 solution look like? What's the minimal change that might have outsized impact? Often we overlook these because we're searching for something grander, something that feels proportional to the size of the problem. But nature doesn't work that way. Systems often have surprising points of leverage where small adjustments create large effects. There's a humbling lesson in the fact that it took 15 years to discover something so simple. It shows us that our blindness isn't a personal failing. Smart, experienced, well-intentioned people can miss obvious solutions when they're looking at a problem the wrong way. This should make us compassionate toward ourselves and others when we struggle to find answers. It should also make us humble about declaring problems unsolvable. Maybe the solution just hasn't been discovered yet. Maybe no one has looked at it from quite the right angle. Maybe the answer requires someone with a different background, a different way of thinking, or a different willingness to question the conventional wisdom. The story of Robert Chen is also a story about the value of listening. In a world of noise and constant communication, genuine listening has become rare and precious. Robert didn't just hear what farmers were saying, he actually listened. He paid attention to what they noticed. He treated their observations as valuable data rather than anecdotal complaints. We could all practice more listening, not just hearing words but understanding what someone is really experiencing. Not just waiting for your turn to talk, but genuinely trying to understand the world from someone else's perspective. Some of the most important breakthroughs in human history have come from people who listened better than everyone else. The tractor gasket story also reminds us that progress isn't always flashy. There were no revolutionary new materials, no breakthrough technology, no elegant mathematical solution, just a rubber gasket and a better seal. And yet this unglamorous fix changed the industry. It saved farmers millions of dollars. It made machines more reliable. It demonstrated that sometimes the most valuable innovations are the quiet ones. We live in a culture that celebrates grand innovations and revolutionary breakthroughs. We tell stories about genius inventors and transformative discoveries. These stories matter, but we should also celebrate the people who improve things in small, practical ways, the engineers who make things work better, the people who find efficiencies that save time and resources, the quiet innovators who make the world slightly better every single day. The tractor gasket is in the latter category. It's not famous. Most people have never heard of it. It won't change the world on its own. But multiply its impact across millions of machines and millions of hours of operation, and suddenly you realize it matters tremendously. As you think about the challenges you're facing, remember this story. Remember that simple solutions are often overlooked. Remember that listening to actual users beats relying on theoretical knowledge. Remember that small changes in the right place can have enormous impact. Remember that your problem might have a solution that's far simpler than you think. But also remember the other side of the story. Remember that sometimes finding that simple solution requires patience. It might not come immediately. Robert didn't solve the problem by rushing. He took time to observe, to gather data, to think deeply about what he was seeing. He was willing to sit with confusion for a while before reaching clarity. The problems that matter usually aren't solved quickly. They're solved by people who care enough to do the work, who are humble enough to question their assumptions, and who are open enough to consider that the answer might be simpler than they expected. You probably have more of those qualities than you realize. So here's my challenge to you. Take one problem you've been struggling with, one thing that hasn't responded to your usual approaches. Try looking at it differently. Ask the people involved what they've noticed. Consider whether a simple change might help. Don't assume the solution has to be complicated. And if you do find something that works, share it, pass it along. Help others who might be struggling with the same thing. That's really what the tractor story teaches us. Not just about engineering or agriculture, but about how to move through the world with curiosity, with humility, with a willingness to learn, with the understanding that simple solutions exist if we're willing to look for them. Thank you so much for watching this video and diving deep into this story with me. If you found value in it, please hit that subscribe button. We explore more incredible stories about innovation, engineering, and the lessons hiding in unexpected places. New videos every week exploring the fascinating connections between how things work and how we work. Let me know in the comments what problem you're trying to solve right now. I'd love to hear what challenges you're wrestling with. You never know, maybe someone else watching has already found a simple solution to exactly what you're facing. That's the power of community and shared knowledge. Thank you again for being here. Keep asking questions, keep listening, keep looking for the simple solutions. They're out there waiting.